Okay, so you should be on page 15 of your book. We're on lesson 3, numbers in exponential form raised to a power. You will see that I have my essential question there on the board. How do I write equivalent expressions for exponents that are raised to a power? All right, if you need to, hit pause so that you can write that down, but I am going to keep going. So it says we are going to have a discussion here, all right? So take a look at this big, long string of problems. You'll notice it's 3 plus 3 plus 3 plus 3 in parentheses, and then another 3 plus 3 plus 3 plus 3, right? And I have all bunches of these, right? In fact, I have, when I look at this, I have 3 written there 4 times. Right? I have 3 written 4 times. Plus, this next group is 3 written 4 times. Plus, I have, what is it? 3 written 4 times. And then I have another 3 written 4 times. And one more, I have 3 written 4 times. Right? Just 3 plus 3 plus 3 is just 3 times 4. It's a lot faster to do it that way. Well, how many 3 times 4s do I have? Right? I've got 1, 2, 3, 4. I have 5 of them. Right? So couldn't I, instead of writing it out with the addition, because I could do this again, I could say I have 3 times 4, and I have how many of those? 5 of those, right? And I could write it out like that and then go, oh, well, 3 times 4 is 12, 12 times 5, that adds up to 60. Now, I'm not saying you have to write it all out, but you could do it. That's going to be a faster way of doing that math problem, right? It's repeated addition just becomes a multiplication problem. Well, what if I change it to all multiplications? Okay, what if I change those to multiplications? So remember in class, when we had repeated multiplication, we just counted up how many of those we had, right? I have 4 of them, and what do I have? I have 3 4 times, right? 3 times 3 times 3 times 3 is 3 to the 4th power. Times, and again, what do we have? I have 4 of these. 4 of what? I have that. I have 3 to the 4th power. And again, I have 3 to the 4th power. And again, I have 3 to the 4th power. And one more time, I have 3 to the 4th power. Well, how many of those do I have? Again, this is a repeated multiplication problem, right? How many of these do I have? I've got 1, 2, 3, 4. I have 5 of them there. So I could think of this as 3 to the 4th power. And since I have 5 that I'm repeatedly multiplying, it would be to the 5th power. Okay? Well, if I go through here, how many 3s did I actually have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I have 20 of them. I actually have 3 to the 20th power. Okay, so 3 to the 4th power raised to the 5th power is actually 3 to the 20th power. Let me show you. Okay, let's try another one. It might have just been a fluke. So we know, based on what we just said here a minute ago, that 3 to the 4th power, right, it's the same, if you notice, there is a relationship between those exponents. So this becomes 3 to the 4 times 5 power, also known as 3 to the 20th power. So if you look at example 2, right, take a look at example 2. We have 7 to the 2 times 6 power, or 7 to the 12th power. Well, what if it has a decimal in it? Yeah, no big deal. 1.3 to the 3 times 10 power. Well, what's 3 times 10? So it's 1.3 to the 30th power. So what do you think the rule is? The rule says if I have x raised to the m power raised to the n power, right? I'm going to have x to the m times n power, okay? Because you multiply the powers. You multiply the powers. Okay? All right. I would like you to do the next group on your own. Okay? So we will pause the video here. I want you to try 1, 2, 3. I know 4 is going to be a little tricky, but give it a shot. See if you can. So go ahead, hit pause, and see how you do. Okay, see what I did, right? Exercise 1, I got 15 to the 27th power. Exercise 2, I got -2 to the 45th power. Exercise 3, I got 3.4 to the 68th power. And exercise 4, I have s to the 68th power. All right, flip over the page. Hopefully you did well. If not, put a question mark by it and see if I can try to maybe help you with it when I come back. All right, flip the next page, please. Page 16. All right, Sarah wrote 3 to the 5th power to the 7th power is equal to 3 to the 12th power. Correct her mistake. What did Sarah do? All right, sorry, Sarah. Yes, you made a mistake, and we have to fix it. We don't want you to keep making the mistake. What did Sarah do? Well, Sarah took 3, and she had 5 plus 7, right? And that's how she got 3 to the 12th power. That's not good, because it should be, right, 3 to the 5 times 7 power. She should have gotten 3 to the 35th power, right? So we have everything there, right? She added when she should have multiplied, right? When she should have multiplied. Okay. Let's see here. A number y satisfies, oh, you know what? I've done this problem. This one's crazy. We're going to skip it. We don't need to worry about that one. That feels pretty good now, does it, to cross that out? That's right. Okay. Well, there's a property that's similar to what we just did. Okay, and it says x times y raised to the n power. And that really can be rewritten. Think of it almost as the distributive property. X to the n power times y to the n power. You can split that up if we need to, okay? Here, let me show you why this works, okay? So x, y to the n power, right? That's the same as xy times xy times xy, right? All kinds of times, xy. I don't know how many times, we'll call it n times. Whatever that number is. Could be 2, could be 17 million, right? Well, this is just a big long string of multiplication. So if you wanted, you could rewrite this as x times x times x times x n times. Times y times y times y n times. Right? I can split the x's and the y's into groups. Okay, well, if I just have a big long string of repeated multiplication of just x's, right? 3 times 3 times 3 times 3 times 3 times 3 times 3, however many times that is, right? I could write that as x to the n power, or 3 to whatever that power is. And then same goes true for the y to the n power. Okay, so that's why this works. Okay, you can physically make it go. So being that you have figured that out, or see how that works, all right, let me do exercise 7 here with you, okay? So there's actually 2 ways we could do this one, but we're going to do what the policy or the procedure I just showed you here a second ago. So this is going to become 11 to the 9th power times 4 to the 9th power, okay? You could write it as 44 to the 9th power. That's totally acceptable, but we're not going to. I want to see if you guys can try problems 8 through 12. Yeah, I'm going to have you guys hit pause and see how you do on this section here. Okay, maybe work with the partner next to you and see how you do. All right, so there are my answers. Check yours with mine. How'd you do? All right, if you need to, go ahead and hit pause, answer and questions, look around, see how you did, try to figure out what I have here. So go ahead and hit pause if you need to, but I'm going to go on to number 13. All right, so number 13 looks kind of like a fraction, and you can think of it that way, and it's really very similar to the last type of problem that we just did. And so what we're going to do is we're going to take x over y to the n power, and you can break it into 2 parts. Just like we did with the multiplication, we can do that with the division. This becomes x to the n power over y to the n power. And that'll make life easier for us. Okay, and let me show you guys how that works. Okay, so let's work with the original. Let's take x over y to the n power, right? If I break this into multiple problems, x over y times x over y times x over y, do that how many times? N times, that's right. Right, I'm going to do this n times. Then what I could do is I could break this into x times x times x times x, right? How many of those? N of those over y times y times y times y. How many of those? N times of those as well. Which then means I actually have 2 problems here. I actually have x to the n power over y to the n power. All right, so it works out just the same way. Okay, all right, that is all that I have for you guys. You will have a worksheet to do tonight, and be sure you have it ready for me when I come back. See you guys later.